So I guess we can start. So as promised, we will have a quiz at the end of the class. So maybe it will be at 9, probably at 9 a.m. And then we'll quiz, and then those who do it faster can go home earlier if you want to. But I will stay until 9:30 to answer the question you might have, as usual. And the assignment 2 will be pre-released early next week because I'm asking TA to check if everything is all right. But otherwise, you'll be covering the material lesson 4, 5, and 6. So today we'll cover 5 and half of 6. So probably you can finish most of the assignment except the last 2 questions. So without further ado, let us start. I hope you don't have any question. If you have any, let me know. Otherwise, I would be listening to you when I am looking at you reply. So I guess I can start. So very quickly, just review what we are doing. In the this is that if you don't see, we are looking at chapter 9, and the previous chapter we talk about regression. And do note that regression, what everything you get is the result of a random process because you are trying to collect data, and data is selected from the population you want to do. It's a random sample. So it means that these coefficients, the intercept and the slope, are random variables. Okay, so that's why you want to see if these random variables are valid or not, right? So you have to do hypothesis testing and confidence level, right? So basically, if you remember this table, which is the most important thing of a class, one off, right? Is you have to look at how you can use this table, right? How to look at the coefficient of the intercept and slope, and this SD, right? Those, and then you divide column A over column B, give you column C, right? And this column C would not be directly useful, but you would use the column D, right? Because from this you can calculate column D, and this column D will tell you whether these coefficients are be valid, right? Because you want to see whether they're different from 0 or not, and probably you want to ask why you want to see whether different 0 or not, right? But if the slope is not different from 0, then basically your model will not be anything useful, right? Because it's not different from 0, then your slope is 0, then it's a flat thing. Then just like you are using only the y bar. X is not useful for any prediction purpose. In particular case, this P is very large, it's not less than 5%. Then basically this regression is useless, right? And the last 2 columns also tell the story, because last 2 columns is the interval estimate for the slope intercept, right? So as long as this includes 0, this is same as looking at this column where the p-value is less than 5%, right? So either you have this or this is the same, right? So that is the way that you would want to look at, right? Also, you want to look at the R square or just R square as well. And today, if time at the end, probably we'll talk AIC and BIC. If not today, will be next class. Okay, so this would be the thing, right? Because we want to see whether our beta is actually the slope is actually 0 or not, right? And also look at the intercept as well. So last time we talked about the gender gap, right? And then we look at the data, and we actually see the in terms of computer science job, which many of you are in the same industry. In the US, in the old days, turned out to be female earn 15% less. Okay, but this is not enough. You have to look at the whether this is different from zero or not. Yes, it's different from zero, right? And the average is 15, but you would say it's between 11% to 80% less, right? But at least doesn't include zero. That means that this thing exists. Okay, it's actually there's a gender gap in computer science. Okay, but does it mean that actually women are disadvantaged? Not that yet, because we haven't established we haven't control other thing, right? Because there's some difference between the feature of the job that women do and the men do, right? So we can't even tell at this moment. So we'll do a multiple regression and then we'll control more things. Then we can say more. But at the moment, it's not. But at least it's so that just tell you men and women, you can ask who earn more, right? On average, the men earn more than women. That's what we can tell. But doesn't mean that men may work overtime, work more crazier job. It can be, right? Or it can be women can be have lower mean but have smaller variance also allowed, right? Because it can be men, can be a lot of men earn a lot, but can be a lot of men earn less. So just say an average. Doesn't say anything about overall. Okay. So just focus on mean. It's just only here. Okay. So there are a lot of things is not saying here. So but and focus on marketing, and then we will see the where's the marketing? Yeah. Where's the marketing thing? Oh, so the typo here, I mean, that should be marketing. But anyway, the marketing is 11%. But when you look at the interval, then it's like include zero. So it means that for marketing, is I cannot say on average men and women are different. Okay. And of course, probably you say it's so negative, right? But because that error is so large, so you can't really tell at the moment. And you would really want more data if you really want to draw any more conclusion. So that is a standard. And that's how you would look at a table, right? And this is computer science, marketing, right? So you will see how this looks like, the R square, those on and so forth. But that would be the idea. And then we also talk about how to draw the confidence interval, right? You will see because the line is your main prediction, right? But you do not really predict a line, right? Because you know the probability that I give you 4, the prediction is here, exactly here will be probably 0, right? Because the probability a random variable equal to exact particular number is probably 0, right? Because that is a minimal continuous variable, right? Remember the analog, right? Find out, pick up your hair, one particular hair, you pick the same hair again will be probably 0, right? So that's why if you want to say 4, then this is the thing that we think that most likely will fall within this range rather than this particular point. Okay. So that would be the guess, right? I mean, this is same as you see. I'm on probably show you again because some of you asked me before the class as well is why we will have a point estimate and an interval estimate. Let me try to look at typhoon polygraph as we do last time. Right, as we'll see, okay, maybe using Hong Kong better. Right, Hong Kong Observatory, okay, would like this kind of diagram, right? This would give you the probability, the more red will be highly likely. So you can see this is the probability graph, right? And besides that, they also have this type of graph is also telling you the model, the mean estimate, right? The line in the center is the best guess, but the area of yellow will tell you about the range as well. So that would be the same idea we have is the line, but we have is also a range. Okay, of course, the range is also getting bigger and bigger because depends on things develop. Then you have to get larger and larger. And same the case in our model is if you are closer to the center of data x bar, y bar, which is here, this is smallest. But when you go further away, okay, the range will be higher because we have a high confidence when the data center, which is x bar, y bar, average of x, average of y, but you're way from the center of x and center of y, then we have less confidence, right? So that would be the idea, same as here. So the confidence interval is asking what might be the average of y would realize. Okay. And I also mentioned which is that's how look at the age as well, but also look at plotting the wage data. And I also talk about a little bit about the but not it's a yellow the pink one is the what I call prediction interval. Is instead of predicting average value, we predict particular value. Okay. And when you predict particular value, that means that you would have uncertainty for each one. Okay. And that means that you would have the PI will be much higher. So if you look at this will be the confidence interval, and this will be the prediction interval. The difference is this much smaller one is looking at if I give you the age, say 40, what's the average salary among those people? If you collect more than one, right? Suppose you collect group of people, the average salary will be within this range. Okay. But if you look at one individual, I just pick up one guy, the range can be that huge. Okay. So that's different between the confidence interval and prediction interval, whether you care about average or care about particular one. Okay. And this is all already you learn in undergrad because I include there because some of you in undergrad learn very detailed, so I have to put them there. But the prediction interval, I don't think is something that I concern a lot, but I want to introduce as well. I mean, I cannot recall if I put it in the assignment. I'll check again. The prediction interval. If I do, I will take it out. But I just make sure. Okay. So then last class we also talked about multi-regression. Is instead of fitting a line, you're fitting a plane. Okay. If you are talking about a three-dimensional world, if you are talking about multi-dimensional world, then you're fitting a hyperplane which you cannot visualize it. Okay. But again, it is still minimize the vertical distance. If vertical means something in the multi-dimensional space, okay, it's just still, but you can visualize it's just the vertical distance minimize the best fit. Okay. It's like this adding. Okay. And I'm not going to talk about the matrix algebra, how to minimize it. But will be the solution will be like this if you look at any textbook. But you will use Python to come up with the answer. So whatever is it, I don't care. I don't think you care as well. And one thing that I want to emphasize is the standard error of the coefficient. This is the second column in the regression. Okay. And if you the table here, remember this is this kind of table. SE is Well, look at this is, sorry, go to the very back. Is this column standard error? Okay. And the standard error means the standard deviation of the coefficient, right? Turn out to be very complicated formula. Okay. But the thing I want to emphasize is the denominator is related to this R squared K. Okay. What's that? Don't need to worry about this because I don't want to go into detail. But one thing this imply the following. Okay. It implies that if you pick many variables, okay, x1, x2, x3, x4, if these variables are so similar, right, then you really can't distinguish what is the cause. How can you then this can be very big. Okay, so so that means that if you try to pick things into the regression, then you can't pick something very similar. So that's a problem of IT data. Suppose you have the data of someone who visit your website, right? And they click this and they click that and they go up and down, right? And probably if they click one button, they will also click the other button. Then if you want to run a regression based on this, and then you have got a problem because a lot of the things actually are so highly correlated. Okay, if you put them on the regression, usually the performance is very poor. So how are you going to solve this problem? Of course, you also learn the machine learning, right? There's some way to handle it. But if you don't want to go to machine learning, one way to do it is using your domain knowledge to combine several observations that you think they're related, right? Because you keep track of the website, you know how many times they spend the mouse on here and there and click and so on and so forth. And you think if they group them together with a meaningful measure, then you avoid this kind of problem. So don't automatically put everything in your regression. You have to think about what are these variables measuring and try to, if you see there's something common, you collect them together, right? Suppose whether they click this A, B, C, D, E, F, G button, they are in the same group or something similar. Then you should want to say combine them, right? Where they click one of those, then you'll be fine. Instead of put them together, because if one click one thing, they all may also click other thing as well, right? So that would be something that have to. Why? Because this standard error is related to how one variable related to the other as well. So if you have that, then you can't estimate it very well. So okay, I don't want to go into detail because otherwise everyone would be super nervous about that, because since I'm not asking in your assignment, not asking exam, not asking in your thing, then I think the intuition is sufficient. And one different thing that when you have more than one coefficient is, beside the t-test, you can do the f-test, okay, which I'll talk very soon. F-test is talking about are all coefficients zero? Okay, look at this question here. Look at this regression here. Why the mouse is not working? Okay, so I want to see if beta 1 up to beta k, all these beta are zero. Okay, if they're all zero, then the regression again is useless, right? So I want to see, can they be all times zero? Is all the f-test. But in general, you don't have to worry about that. But there's something you have to check as well. Okay. Now let's go back to this question. Okay. We are looking at the gender gap, right? But we know that our wage doesn't depend only on gender, can also depend on experience or age. right? And we generally know that men retire later than women, at least in the US. US women retire later, earlier than men. I don't know, in Hong Kong maybe same time, but in China is probably noticed earlier, right? And Hong Kong may be same, right? But this was the case. So if you run this through regression, right, we'll show that this is negative, right? Because the gender gap, right? And we also saw in the last class is age is also positive, right? Because the more time you work, you're more experience, the age is capturing experience. The more experience you have, then usually you have higher wages, right? In general case, right? Of course, these days in IT, probably, I don't know. I mean, probably the until 35 is increasing, but after 35, probably, I don't know. In some cases, decreasing to 0, right? Well, I mean, I don't know here, but at least I know many places in China, right? After the first 5 years old, then your wage may be subject to a substantial cut, unless you can prove you're better than others, right? I mean, that is not something old. If you look at things in Japan in the 1990s, that happened the same. So when the financial crisis come in, and then people will try to optimize, their labor force. But anyway, so since as we said, we're expecting the female would be younger compared to, I mean, be retired earlier, right? So that means that I would expect, right, this regression is overestimate gender gap, right? Because the age effect is not there. Okay, age would explain some of the wage difference. Okay, so that's why we run this regression. This thing should be smaller. Okay, and that's negative. Okay, so that's what we're trying to do. Okay, remember this formula. Let's run that again. So this is data. I know NumPy and Panda, and your else like this. I think we have to swap this guy because of the way that the OSF have done. Let's check this out. I think chapter 9, right? Yes. So we have that. Last time we where am I? So this data. So make sure that you swap because the OSF is they change their logic, so you have to swap a little bit. Chapter 9. It's still loading for some special reason. It's still loading, but let me go to slide first, okay? And then we look at the female and look at the average. Look at the female equal to 2, right? And so this bracket means that become a logical statement. If this is true, this is 1, otherwise 0. So you can use the assign if you can use MP where 1 or 0, or you can use this. It's also fine. This is a trick that you can use because it is asking whether equal to 2. Equal to 2 is 1, not equal to 2 is 0. Okay, so and this is the weekly wages, and you take a log. Okay, and here we just look at data where people work more than 20 hours, earn something. Age is between 64 and 24. Okay, and then it is grade 92. I mean, the graduate from 1992, and the data is 2008 something. So it's I think it's 44. What's 44? Okay, it means I forgot why it's 92, but anyway, it's just means your college about 92 weeks. I forgot. Okay, so once you run this, right? You run the female and the female plus age, right? So and use the Stark laser to run over. So this is the regression, and this regression you can see with the female is earning 19% less salary, but as we see the female retire earlier, right? And usually you earn highest wage at the end of your career, right? So that's why this will explain some number there, and this reduce 1%. Still, even you increase experience, it's still the woman is at disadvantage at 80%. Okay. So this is I think the whole data set doesn't not only just the computer information technology. Okay. It's still running, but let's run to here. Yes. Female. Yeah. So this is the regression we have, and we can continue running all this crazy thing. Once we're done. Okay. Oh, this is from the last chapter, right? Oh, we are here. That's good. This is this is here. Okay, we run this regression. Okay. Now, once we run this, then we want to look at another regression. We want to look at H square. Why? Because when you look at the data, okay, as we see, age distribution is not uniform. Okay, and there's a lot of people actually in the middle. Okay, compared to 2, and it's not linear. So this is a contradict, right? The age distribution. So that's why it would allow us to think about H square. Okay. So of course, it is well known in economics that as we see, right, the experience is increasing at the beginning, as I said, right? The big drop is like 35. Right, 35 is good, but after 35, then you drop, right? Because before 35, you can 996 for a very long time, right? And after that, you cannot influ, right? You cannot join, right? So then you can go down, right? So that means that you have to create a square term and run the regression again. Okay. And I create a square term and run the regression again. And you combine, this is what we see, but let's look at the data. Look data here. Okay. So you will see, even if I add a square, it's just a slight drop from 90% to 19.5, but 18.5, 18.3. So it just, the square term is better. Okay. In terms of R square, you can see from 3% to 5% to 6%. Okay. The R square increase. Although the result doesn't change, but it's much better fit. Okay. Of course, you may say, well, that is too low to be anything useful. But remember, we don't put many variables here. We just use female and the age, right? It doesn't include a lot of stuff. Potentially, the wage to be more than this, right? Have a lot of stuff there. So that's why it's okay, right? If you want more, probably you want to look at where they study and a lot of stuff to explain. But we just have that. Okay. And after that, I want to talk about what we call the interaction, which is also important in regression. In the beginning, okay, when we run the regression here, okay, regression like this, is saying that the wage, okay, sorry, the female only affect your wage, log wage. Log wage means the wage growth rate, right? And this is the what female effect does, right? And just affect the level, okay? And but this is possible. Female also affect how your experience change your wages, right? Maybe females start at low wages, but their wage can go very fast. It's also possible, right? Or it's not about starting point, it's about how it grows, right? Maybe they start at the same point, but female maybe grow slower. It's possible because maybe female at home taking care of kids, right? Maybe they're willing to sacrifice the family, especially for the US, the classical conservative woman, right? They value family more than money, right? That's what they do. But of course, there's a classical Christian conservative people would think in that way, but may not be right or wrong, but that is might be possible. So we would consider the case of interaction. So this one is like the wages, other variable. This is the female affecting the up and down, right? But also you can allow this to interact, okay? So it's just like the impact of the female would depends on different ages, okay? It's not a fixed number, different slope, okay? Or more complicatedly, okay? If you more than two group, then you say group one, group two, and you would interact the group one, group two with the X as well, okay? So in that case, you would be fairly complicated. And also, if you allow any variable, you can also interact them, okay? Any continuous, not any discrete. So everything can be interact, okay? And this actually related to a math concept is you can have any degree polynomial, okay? Can approximate any continuous function, right? This is something from your high school math result, so college math result maybe. If you do M2, you know it, right? Because Taylor's field approximation, any defensible function, right, can be approximated by nth degree polynomial, okay? And that means that you can always interact with anything, then you can approximate anything. So it's very important. So let's see this example. This example will be regression with wage is affected by female or not, explained by your experience, which is kind of wage, and also the growth rate of your experience can be depend on your female or your male, right? Maybe female, they are learning faster than woman, I don't know, or man or woman, I don't know. Let's see. Okay. So what you do is you run the regression, okay? And to run the interaction is very simple. You don't need to create a new variable. You just use multiply, okay? Then you're done, okay? Because the code is the same, okay? You can see the regression 5, right? Same as the wages, okay? And here I limit to female, okay? There's no query, the data I just restrict to female. and I run the regression. I just limit myself to male. Now I run another regression, which I regress female age times female. Okay, so this is something I want to care. Okay, and I just use the Stark laser to combine them. Okay, and in that case, I will see. Okay, for women, actually, your experience actually doesn't grow as fast as men. Okay, men, look at the wages. Experience go faster for men than women. Okay, so one of the reason probably maybe men don't have interruption due to having a baby, right? Because usually when women have a baby, they will be away from labor market for 2 years or 1.5 years, or at least 10 months, at least a few months at least, right? So that grows slower. Okay, so that's why we will see when you interact. Okay, this female is no difference, but you can see when you have regress on this female is 0.9 and the interact will be 0.3 because this plus this would be this guy, right? Because female times age. So female would grow slower, right? So that is the regression. And you will see that's what we want to conclude. Okay. So basically, we cover how you would do the regression with a lot of different kind of thing you want to explain there, right? Because basically, it's very simple. It's just this regression thing, okay? You can add as many things you think that is relevant, just put there, right? And then you have fun and run the regression, right? You can run as many as you want, and you try to see whether they are valid, right? And then you will check, right, whether you have star or not, right? If you have 3 star, then you leave there. If no 3 star, then you forget about it, okay? And interestingly, okay, you will see when I run this regression, it's no longer, this thing no longer have stars, right? So it is, the gender gap doesn't come from the initial wage difference. It's not men earn more than women when they start a career. Rather, from this regression, we know is men wages grow faster each year than women. Okay, this is our conclusion. Let me repeat the statement because I want to make sure it's clear. Right, when you don't look at this interaction, right, we conclude that actually men earn more than women, right? And but when you control how fast the wages grow, okay, actually it's not men earn more, right, or women earn less. Okay, it's not about the initial wages. Okay, it's not about it because that's what I say, right? It's not the growth rate is lower, but rather is the how they interact with the ages or experience, right? Is look at the salary increment, the wage is the men grow at a rate faster than women, and that is the driving force. It's not the starting point, but rather is how the growth rate. Again, one of the reason probably maybe as I said, men in the US, right, can just work like crazy, and some of them didn't get married, right? I mean, some men doesn't get married, and then they just keep working, right? And also men die earlier anyway in the US case, right? They work more crazy, they die earlier, and women live longer, right? So, but that's true, just the data, right? It's not nothing to judge. And women also tend to take care of family more, right? And they would work less crazy than men, right? So on average, this is what it does. It's not about the initial point whether the salary is different. So it's about the growth, and the growth can be explained by a lot of stuff. Okay. So in that case, right, if you're economist, then you would suggest is, okay, it's not about gender difference. It's maybe, say, family support, right, can make the wage equal. And that's actually what happened in Hong Kong. I think Hong Kong is, or Singapore, is one of the few places where the gender gap is the lowest. One of the reasons why is domestic helper, which largely equalize the men and women job opportunity there. Okay, and that's why it liberalized the household wife to go to work. And of course, Hong Kong is also one of the places we have fewest baby in the family, so also contribute to that as well. But anyway, it's not an economics class, so forget about what I said, just statistics. So next, we have R square. I hope you remember what R square is. R square is how good the fit the data is in terms of regression. Okay, and when you have more regression, you of course this thing will always not reducing because SST remain the same, and you fit more variable, the SSE cannot drop, right? Because you fit more, the worst case is you put zero coefficient on those things, right? So you adding more regressor, this thing R square must go up, right? Because suppose you fit the first regression, that's the best case. You add out the redundant thing, you can put the coefficient zero. Okay, so adding more coefficient would just make the SSE smaller and smaller. So always not decreasing. Okay, so it's not desirable. Okay, because I want to check whether adding the new thing would be meaningful or not. Okay, I want to add something only if meaningful, right? So that's why statistician have an R adjust R square. Okay, you would do something very similar, but you divide n minus k minus 1, n minus 1. K is the number of coefficient you're using. Okay, so that means that if you use more, minus k, so this guy is bigger. So that means that adjust R square is adjusting the number of coefficient. Is very useful when you compare big model and small model, right? So you want a bigger model only if it is sufficiently reducing. So that is the adjust R square. Okay. So that is the table I mentioned at the beginning. You see the R square. So let me go back to the beginning table. Okay. Remember this table? We have R square, adjust R square. Okay. That is what adjust R square means. Okay. Okay. So lastly, I want to show one very useful graph. It's called the y hat plot or y hat y plot, whatever you like. Depends on what you put in a y hat or y. So what we're doing is this. Okay, of course, you would be curious what it's doing. Without showing the code, let me show you what I'm plotting. Okay, what you're plotting is from your data, you have a y. Okay, and y hat is actually from your estimate. Okay, if your y hat and the y are the same, your perfect fit, right? So you will end up in the 45-degree line. Let me draw what I'm talking about. So this is what this YY plot is doing the following. So I have a line, I have a scatter plot. Okay. Okay. Suppose like this. Okay, this is X. I just use linear regression. Okay. Just simple linear regression. Just one variable. Okay. And I would fit a line, whatever, right? And you will see, okay, for this X, right? This is the Y, but this is Y hat, right? Y hat is your model, Y is your data. Okay. I want to put these two number into a scatter plot. That is a Y hat plot. If Y hat plot is 45-degree line, then the line is perfect fit. Is that clear? So Y is your data, Y hat is your model. Okay. If Y is bigger than Y hat, okay, then your model is underestimated. Right? If Y hat is above Y, your model overestimate. Okay. So now let's go back to the graph, because this is very useful graph to have fun. Okay. But so perfect fit, right? If below diagonal, right, then you would be underestimate. Above the diagonal, we will overestimate. Okay. Okay. Because this is Y hat Y plot, right? If your value is Y is here and your Y hat is above, right? So your Y hat above Y, then you actually underestimate. Right? Y hat is here. And if your Y is below, right, then you overestimate that thing. Okay. Anyway, how can you predict? It's very simple, because to draw it, it's just like you have some result, you predict there's a Y hat, you just plot the scatter plot Y hat, right? Having the same scatter plot. Now, go back to the data. We talk about the hotel, right? Remember our very beginning question, the first class, is we want to use the data to find the best deal. Okay? How to find best deal? Run the regression. The regression tells us what is the average, the model from there. And use the Y hat plot to figure out which hotel is our best. Okay? So we run the regression, and now we run a better model, the price, not just distance, and also the rating, because we want to not look at the cheapest price based on 1-star hotel, 2-star hotel, right? Based on the rating as well. So of course you can add more, but just focus on this. Okay. And here is same. I download data. I'm not going to run it because I think it's easy. And you clean the data, we've done the same time many times. I think you do assignment 1, you know it already. And then this is new, right? I have the OS, price, distance, rating, but of course you can add more. And I use data, I fit it, and I use the Y and Y hat. Nothing new here. And once I do that, I draw a line to plot a line, and do scatter plot to plot it. Okay. So I have the Y hat or Y hat Y plot. So okay, this is my price, and this is my predicted price. Okay. So which hotel you find is good. Okay. If along the line that is fitting what you think should be, right? Now, if your predict price is 60 and it's sell 60, then you fit the model, right? So if predict price is this, is way above, then is overpriced, right? So how you find the lowest best deal depends on what you think. Is the lowest best deal, you figure out something, maybe the biggest distance, right? Probably this one is the biggest deal, right? Because suppose it's 120, but it's charging like $50. Then it's a big deal for me. Okay, so that is how you read this graph. Of course, sometimes you will flip the Y hat Y plot, but I use this plot. Okay, of course, this is the most insane scam, right? Suppose 100, but you're charging 400, right? I don't know where it is, but definitely not Vienna, maybe somewhere Southeast Asia, right? So that would be something like that, right? So that would be the idea behind. Okay. So I guess I do the regression. Particular, I want to remind you that this is the main key new Python function you need to know, because this is random regression, right? Because you'll be using the statistical method model formula, ORS, tell us Y, what's X, what data is fitted, okay? Although I didn't, you can use XC3 or you don't have to, and then you just plot the graph and figure out what is it, okay? And that's the main thing I want to show you, and also you want to know how to read in this table, right? Check the coefficient have star or not, how to interpret this coefficient, and this is what I want to ask, okay? And there's something that I want to know as well, but of course later when I release the probably I'll later release a sample, because this year I teach the part-time class. Last time I teach the full-time, so I will not release the past paper, but I will release a sample paper, because the different, right? I release the last year paper, doesn't really useful. So I release a sample exam question, which I also do in the first year I teach any other class. So I will sample exam question that would similar to what in terms of topic, what I'm asking. So it will be very similar to the full-time exam, but because the scope is different, so I have to adjust accordingly. But you will see this as one of the questions I'm asking as well. So you will see what kind of question I'm asking, but this is mainly I want to know, okay? Anyway, let's break of 15 minutes and we will continue for the next set of slides, lesson 6. So you can fill in this one if you have time.即係話佢可以成為嘅，即係話咧，佢哋女人佢嗰個佢個經驗男人嘅家庭嘅男。咁你應該嗰個係咁嗰個1年㗎嘛，佢1年係一個 W 嘅。擺明嘅一年我因為你係有用，你有先明白呢個數我唔會影響到佢如果考慮得成啦，你做所有路線嘅反應，佢點解要做係數啊？我哋想問咧，我哋做咗成間做呢個事嘅。應該是發展上都會你撳嗰啲嘢，你先撳到咩？我哋所寫啲嘢，你頭先你自己你翻去跑啊，你去江門跑上做我出嚟做數嘅嘢，你嘅手一樣，第一樣做出嚟，你嘅手係呢個其實你抄法，我有個係咪你一時間唔出？呢個 唔使你 out square。That's why 我 out square 你講咗，你即係 compare 我個 regression 嘅時候 ，F 佢冇乜大意，因為你嗰個因為你好多嘢你好多嘢打落去㗎嘛 ，out square 細啲。你跑都係，不過唔對咩？你做 regression 你嗰人好 cool 嘅，即係你擺嗰樣。你留嗰啲同你嗰樣有關嘅，呢度講啊，你留嗰種會唔會貴啲？啊，哦，但係講你聽不，係啊，或者係啊。你知道呢個方法係咩？呢個是係嗰啲什麼？但係我肯定係嗰啲係畫得少，隨便睇下先。即係你係要講咩？係所以個 regression 呢個 data set 同 data set 但係咧，我個 data set 我個 data 唔同個 model 唔同 output 咁可以我咁樣有 absolute value 同 output 個 data set 就真係發現之咁你睇佢呢都要大好嘅，咁但係你個最大好，你個正大好啦，咁但係比特殊 set 佢嘅啦。All square 我呢個佢專利嗰個係必將，但係你嗰個，但係你個問題最緊要係成喺呢個。我 RMS 用唔到佢。其實 explain 幾多 percent 冇所謂。即係當你呢個問題，你想喺唔加大嘅問題，你我咧呢度係個 question 呢個呢個做嘅啫。我睇 feel 過，我係解決 SSC 嘅問題。我 slide 嗰度睇 feel 咗啦，我啲 friend 啊可以解決呢個。RMS 呢我哋呢個我有冇睇過？是但整，係啊。SSV 可以細啲嘅，即係嗱，因為你做得啦，我哋 SSV 話通常我哋唔追佢話。而家你講個情況，嘅情況，接受啦，係啊，我哋有收收。會多啲佢非常係所以 output 通常10幾人至30幾成嘅。你要多期可以嘅，係咪？加啲 left turn 可以講啊，我唔使個大佢10個。我以為你嗰啲嘢係少啲同其實嘛，我哋會 output 你 prediction 就 大 WiFi，呢個梗係 explain 嘅 explain 得曬。不過個 destination 講緊你明知個 regression 都佢相關亦都係好大，你 explain 都冇鬼用翻嚟啫。係啊，即係你講緊你想你哋招牌。問多你啲嘢真係，唔係好明嗰個 table 點樣睇？點樣睇？邊個 table？係咪 regression table 嗰個？你有個咩 woman？female。哦，呢個點理解呢個圖？嗱呢個就係話咧，你個 weight 啦，你 woman 嘅話咧就係每多一年咧，你就多0.6個百分比咯，係增加嘅。咁 man 就係每一年差唔多增加1%啦。咁即係話個 man 男人嗰個工資增幅係高過女人咯。我哋睇個 regression 就見到，哦，其實男人同女人呢個工資呢個雖然係女人係慢啲，但係個 P value 冇 star 噶嘛，即係呢個冇料到咯。即係話男人同女人嘅工資開頭佢嘅差別係冇。點解之後會有差別咧？就係因為佢嘅工資嘅漲幅不同。男人嘅漲幅就係1%，女人就漲低過0.5，即係低咗0.3嘅百分比咯，每一次。咁所以佢呢度0.9%，其實呢個係咗男人嗰個 age 嘅增長。係啦，咁女減翻0.3%就係女啦。係啦，就係女人就慢啲。咁呢度就雖然佢冇 star 啦，咁但係佢 suppose 就係嗰隻睇女人。睇個冇 star 咪真冇得到嘅呢個。就係假設。即係唔係即係冇咯？即係話男人同女人冇分別，佢嘅始終工資冇分別。分別係喺佢個增長有分別，即係男同女人咧揾第一份工嗰陣時咧係一樣嘅，但係因為咧 on average 一樣，咁但係女人咧就係佢可能往搏啊，或者男人癲啲啊，咁咪上飲多啲酒，咁咪上得快啲咯，多啲煙飲多啲酒啊，咁咪跑得快啲咯。咁呢個 constant 係代表啲乜嘢？即係喺第一份工。佢唔係男人女人，一開始就係 log 就係3咯，咁咪你剔翻 exponential 佢呢個咪佢個第一份工嘅第一份工嗰個工資咯。咁但係一個男同女會唔一樣嘅？咁呢個男同女會唔一樣嘅？如果係 initial 因為分開男人同女人啊嘛，好少嘅。咁你睇呢個冇分別㗎。有分別，但係你攞到啲分別。其實呢個3.117啦，其實我再減翻0.36%。係啦，咁就係呢個，但係個分別係細到分別唔錯啦，咪係分別嘅，但係分別細得就係不足以為分別。好得你咁樣啫。如果你得一個冇分別嘅。你有相別嘅喎，佢夾埋咗，反而係細咗少少。係細啲，因為你一個係just square 你係 乘出嚟你係會乘多個你多咗個倍，唔係減 K 嘛？你個分別就係呢個嘛？你有個減咗 K，如果你 K 係1嗰陣時 ，K 係0嗰陣時，你咪完全抵消咯。你多過1個嗰陣時，你咪會呢個咪有啲唔同，即係話你會多嗰陣時，呢個會adjust R square 細啲。
我就係佢，因為你加多咗啲 coefficient 嗰陣時個 R，
即係你加廢嘢咧，adjust R square 會下跌。如果你無論點加廢嘢 ，R square 都係增加嘅。但係你加垃圾咧就會 adjust R square。
即係有，
所以你要加啲有嘢有料到先會用。所以我哋
咁我哋睇
咁machine learning嗰陣時，你要 adjust R square 嘅。係，其實中 R square 得嘅，不過我哋通常用 adjust R square。
即係其實嗰個 variable 咧，垃圾。
即係你加啲垃圾落去，佢會下跌㗎。
係啊，咁佢會下跌。
佢會變負都有可能。R square 定0個之間㗎嘛？係 adjust R square 可以變垃圾，可以變負數嘅。
係咪有冇 range 㗎？定係冇range？
可以負。
但係因為我睇你呢個 regression 咧，我睇唔到有 male 嘅存在，我就係見到你呢度有咯。
female 就係1同埋0，female 就係1，咁 male 就係0。
即係其實你冇寫出嚟嘅。
唔係，咁我只係呢個 run 出嚟解釋下嗰個點解啫。我 run 2個，我 run 3個 regression，即係話你只係 run 呢個啫嘛。我解釋呢個點樣嚟，呢個點樣解釋都得，亦都跑兩個。
即係其實淨係你嗰個公式就係睇翻最後嗰個。
係啊係啊。
哦。
睇3。
唔係呢個點樣嚟？呢個咪呢個減俾佢哋呢個 as you said。我冇講一個冇所謂咧，就係。因為呢個即係話女人呢個男女喺第一份工嘅 wage 係冇分別嘅。
好細咯，0.36%。
係咯，但係呢個 SD 大到基本上分唔到。
good hole 入邊嘅意思係咩啊？哦。
係啊。0.9減0咩？因為呢個 female 係第1嗰陣時，呢個就加咗。咁你佢全加埋就呢個。因為呢個係男同女噶嘛，咁呢個係男人嘅，你冇呢個就係。咁呢個加呢個咪變咗2個加埋，女人咪就呢個。呢個
因為 O 就包男人加女啊嘛，
男同女一齊考。
呢個係男加女啊嘛，呢個數字係。
係啦，就係男人啦，
就係正男人。呢個就係男加女，所以呢個加咗女人之後就減0.03，所以就男加，咪所有嘢加埋一齊就係減咗個女人。
即係呢個其實係男人同女人之間個 difference。
冇錯。
因為主要有少少亂就係，因為你上面條regression 呢條公式咧就講緊，淨係講喺呢度，因為前面嗰兩橛就
我就話俾你聽啲點樣嚟嘅。
OK，
但係你唔係喺呢個嘅，就呢個得㗎啦。係呢個啫。
OK，咁我明明地，唔該 ，OK 啦 ，thank you。
So I guess I start to reply to you, please. Full mark, please. I guess it's not hard to get full mark for the quiz, right? More than half, I guess most of you get full mark last time. Why I need h square? The reason YH squared? Because I can see the distribution of H is not linear. Okay. And also we noticed the effect of H is going to experience is going to be nonlinear. In general, right, you can imagine experience is important when you are young, right? When you get older, it doesn't really help you a lot, right? At the last, I mean, or you can imagine exponential depend on where you are, but usually your growth rate of the wages is highest when you are between 30 to 50s, right? And the salary growth actually is at that time, right? So that's why you want square. It's not linear. Remember why you want the linear take log or those kind of transformation, because of it's not linear, right? And you want to fit a line, then it's better to fit a non-linear. Remember last time we talked about this chapter? No. We talk about I think lesson 4. Remember why we do contracting? Actually, we do this last time, GDP, right? The GDP, we fit GDP and GDP square, right? Because we know that when you get wealthier, if you remember the data, right? The data here is like, it's non-linear, right? It's growing at decreasing rates. So you fit a contracted term will a better fit. Okay, so that is the reason. And for prediction of 87, why I use the whole data set? 87. Oh. Why is it DF? The reason is because of if you use ORS this thing, DF, then you just when predict, you can use it. You put in the whole data set, then you're done. You don't use to put X, you can put the DF. That is the Python code. Okay. If you use the not the formula, then you have to just put X. So I guess I answered your question, I hope. I'm confused why no more star after female times age. No more star? No, we have female times age, we have star. We have C3 star here. Are you asking whether no more star? Oh, initially, if you don't have this one, right? The only difference you capture is just the initial, you capture is the wage difference between male and female, just only coming from initial wages, right? You force them to, you don't allow them to explain by the growth rate. But now with that, it's actually not the absolute difference among each one. So let me draw a picture, so maybe it's easier to see, okay? So what's different model here? So let me collect this. It's important to explain this to you, otherwise I'm not doing it justice. Go quickly. So initially, what we run the regression like this is age and wage. Of course, it's log wage, right? And we said the following. This is I call it W, right? It's log wage is equal to alpha plus beta age, right? And what we figure out is, okay, men earn more, okay? And actually what we are saying is actually we run the regression, we figure out this is the case. Log wage, right? is alpha plus beta H. Okay, maybe actually this prime here. Okay, this is alpha prime, and this is alpha. Okay, and we are forcing our slope the same. Okay, and we're saying this coefficient is like 20%, right, or 19%. Okay, and we're saying that at every H, they must have the same gap. Okay, and we say this actually run this regression, right? This is the regression we're running. Log wage equal to alpha plus beta H plus gamma female, right? That is actually what we are running. We're running this regression, right? And the female can be 0 or 1, right? If female 0 is go to male, right? Just basically give this, right? If female is 1. And if female is 0, female is 1 is here. 0 will go to above, right? So it is saying that you're saying when you estimate this model, you estimate 2 lines here and the constant gap. And you capture this is what we call the general difference. It's by this model. Okay, when we run this regression, we're saying that every H, the difference between male and female are a fixed constant. If we make this assumption, the gap we estimate is 80% or 90%. Okay, so this is the model we have. And when we run the model we just see with interaction, what we are doing is a more generic model. Okay, we are running a model. Let me have a new page. Instead of parallel line, what we are doing is the following. Okay, when the model is log wage, right, equal to alpha plus beta H plus gamma female plus where am I? Alpha, beta, gamma, pi H times female. Okay. What would happen when we estimate this is when we do this means that we will have 2 different lines. One line is for male. The other line is for female. Okay. We allow ourselves to have different line. Okay. Okay. Have different potential, different intercept. Okay. But turn out our regression, we figure out that the intercept are no different. Right? There's no star on that one. Okay. But actually what happened is like this. Okay. It's not initially the female and the male have different wages, but rather male grow faster than female, right? Because if you try to do this, what you see is this regression means the following, right? Is log wage is equal to alpha plus, because female, alpha plus gamma is coefficient, plus pi of H, right? Will be this the formula for the female. For the male, will be log wage is equal to alpha plus beta H. Okay. And the gamma, okay, is the coefficient of the first line, which is not different from 0. So that's why that is the same. Okay. Gamma is the first line. And the pi is the female times H is negative 0.03, right? And this is 0.09, right? So that is how to explain this model. And That's why in this model, it's more flexible, right? You don't say that the average gap can be anywhere, can be different slope, can be different intercept. So this model is more flexible. And now we figure out that it's not the initial weight different, but rather they grow at different rates. So this is what we found from the data. Okay. Is that clear? If not, then ask me again. I'm happy to explain again. Hopefully not confusing you more than before. Can we make assignment 2 optional? If we make everything optional, then we have to make the exam more difficult, right? Can I explain the regression result again? Which regression result? I get that is a regression result, I hope. But maybe can you explain which regression result I need to explain again? In the upcoming you reply, otherwise I honestly don't know which one you're talking about. Okay. Thursday is okay. Oh, the weather now is sunny. Maybe, I don't know. Yeah, salary growth slower. More regressor, R2 is higher, use just R squared. That's true. Exam is coming. No, that's far away. Why is coming? It's still, we only have done 7 weeks, right? Or 8 weeks, right? So we still have 1/3 to go. Okay. I guess I'm a little bit fast today. Okay. Okay, I see. Okay. I get it. I will be slower. What is star 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 mean? Star 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 is a t-test. The p-value is 0.01, which means that it's different from 0 enough. Okay. For our application, basically you say when you don't see at least 2 star, right? Then basically this is not different from 0 enough, right? Then basically redundant, right? Because you're looking at 5% alpha, right? 5% type 1 error. Okay. If there's no star, basically we'll think this is no different from 0. Okay. So that's why when I draw the picture there, right, I just draw it the same, right? Because I thought they're no different to me. Okay. Do you know if depend on how you transform, if you just normalize it, standardize it, doesn't change. Of course, you take log nonlinear transformation, of course it will change. Right? You will change the multicollinearity we can amplify by, you will. Depend on what kind of transformation. Right? But if you just divide by its own mean and divide by its SD, then no change. Okay? You can check it. Okay. You can just run the regression, right? Just run regression, transform the data, run the regression again. No change in R square, other thing as well. Okay. God bless us. Yes, I do agree that. Study is not getting for an A. I guess it's true, I guess, right? Because I guess to come to here is not getting for A. Because coming to the class doesn't help you in A anyway. Just helping you to understand what's going on. The machine I most use in the gym is the vending machine. Yeah, that's good. That's a good joke. Wow, that's a good claim. Y intercept is the same. So that's what he said. the female coefficient is 0. Look back my regression. Look back. If female is 0, okay, female is 0. Okay? So there's no gamma. The intercept are all alpha. So they must start the same point there. Okay, so far so good. If still a question, feel free to ask me again. I'm happy to answer them. But of course, I do understand I cannot satisfy everyone because I said everyone will be too slow. But if you do have a question, then feel free to ask me. Okay, I'm happy to answer a question. Or if you do a question, just try to send me an email. I try to answer them. Okay. So the reason why I want to speed up a little bit because some of you actually want me to cover the LISO, which I didn't want to cover, but some of you actually want me to cover, so I just have to spend more time on that. Okay. So lesson 6 is about prediction. Okay. So this part probably would be somewhat a little bit overlap with your machine learning class, but I hope it's okay because you want me to cover it. Okay. I didn't want to cover it, but because I thought it's overlap. But you want to cover it, so I have to satisfy. N is more than 10. Yeah, N is more than 10. So I want me to cover this part. So, but don't worry, I'll just try to give the idea. Okay. And because after that, we talk about after this chapter, we're doing chapter 6, right? And 7, we'll get to the real business of prediction. Okay. But this chapter 6 is the end of the regression thing. And then we go to simple regression after that. Okay. But now we're going to a regime that is still prediction. Okay. So we just try to find a model that best fits. And then we will try to tell you how to LISO to some selection there. Okay. But not clear how much I need to cover. If I'm too fast or slow, let me know. So the idea is you want to predict using X to predict Y. And there are many in this literature, Y can be called many names. You call dependent variable, response outcome, and X can be called covariate input independent variable. And basically, you want to X to predict Y. And the model, we call the original data, okay? The data to build the model, and the live data is data that are with some target observations, okay? Just some terminology there, okay? And probably this you learn in the machine learning class as well is in our model, we mainly focus on quantitative prediction. We predict a Y which is continuous. And in the other class, you learn logistic regression, probability regression. The Y is a probability for binary variable, whether yes or no, but you predict a probability over there, right? Whether it's yes or no, but with probability, right? And classification is to force you to say 1 or 0, okay? But for our purpose, I only focus on the first one, okay? You learned it from other class already, okay? So I just focus on this one. Oh, don't open your eye that wide. I mean, I only covered this one. Okay, I only covered this one. But I mean, to be fair, there's no difference in terms of methodology. Okay. So again, probably you would not be surprised. Is we want to minimize this guy. Okay. Either you y minus y head one way or the other, right? This is the model. This will predict. I want to minimize this guy, right? Regression is minimize the square sum of this, right? Sum of square of this, right? SSR. And usually to minimize this prediction error consists of 3 parts. You will learn this actually in machine learning class very well, right? One is the bias, whether it's overfitting, underfitting, whether you have the model more complicated than what it might have been or it should be, right? Or you have less feature in the model, bias. And the other is the model error, which you fit the wrong model. And there's a genuine error, which you can't avoid. Okay. So basically, just focusing on bias and model error, right? Because genuine error, you're never able to do anything about that. Okay. And the way to model this is to impose a loss function here. And the loss function here is always square. And the reason why you want to minimize the square, there are many good properties. The first property is symmetric. It doesn't really matter you're above or below, at the same. And second, is square, is convex, means that if you're far away, it will much higher. Okay, so that's why we use the square version. Okay. And we know already, actually also in the classes, you would care about the MSE and RMSE, right? The reason some of you would notice is if we just minimize the SSE, then you add more data, then SSE will get higher, right? So we actually want to avoid this problem. We do the average, okay? And some of you would do the machine learning, would notice when n is very large, this thing will be huge as well. So we take a square root to make sure that the scale is manageable. So that's why when you run a lot of machine learning code, then you do the RMSE, right? Because this code, the size will be much reduced as well, okay? And when we look at the mean square error, that's very important, right? Is this decomposition? I bet that you learned it in machine learning class. Is decomposition 3 parts: is bias square, prediction variance, and error, right? And depend on what the true model is, but it's always the case that if you don't forget about this thing, there is always about the bias and variance trade-off. Okay, if you want to reduce your bias, you increase your variance. If you want to reduce variance, you increase your bias. There's always the problem like this. Okay, so later you will see what do I mean by that, but this is always the trade-off in machine learning is always this and this. And this comes from this equation, but I'm not going to bother you with the math because I'm pretty sure you learned it in machine learning class. I hope, different from her class, sorry, I show you another way to do this calculation. So the example we use is a used car data, okay? And the data is grabbed from a website, and use the car based on different variable. You can see the thing we want to look at the price, right? And the price can be dependent on many things. So in which area, the condition, the car, which year is produced, conditions, odometer, right? How many miles have drive, and what type of car you have, right? Depending on the fuel, cylinder, color, and whether you sell for a dealer or not, right? So I like this data. It's actually interesting data. So the data here is we want to look at the Chicago data, okay? And we will do some data filtering because of not all the feature, all the data. So we try to drop the data with only very few data, the condition new or fair because we don't have enough data. And I don't want to drop the truck because we want to buy cars and only use the auto, not manual, because not enough data. So that's why we drop them. And if the price is too low, probably a scam, so we just drop it. Okay. So look at how they clean the data. Okay. Again, I'm not going to run it because for the time, but you can run it because the code is already on the website. But just make sure that you swap this guy because when you run it, but on the Google Code Lab is already swapped. Okay, you can run the Code Lab one. So NumPy, Panda, URL, data. Okay, and focus on Chicago, and focus on the condition. This is not okay. The condition is not is new and fair, but I want to ignore them. So I use the snail, means not. Okay. And I also don't want manual. Okay. So that's why I take out the manual. And I don't want truck. So that's why I have snail truck. Okay. Is that clear? I think it's very intuitive, the code. And as I said, if the price is below 500, probably a toy car, right? And if the price is too high, probably not going to be relevant anyway, right? And if the car is too new, only drive 100 miles, sorry, then probably it's not going to be relevant as well. Similarly, if the price is less than 1,000 and something like new, or the age is too young, less than 8 years, I just also exclude. Okay, just focus on something is reasonable. Okay. Here is just decoding, and here excellent, I will call 1, and dumb equal 1. If this is good, I call a good condition 1. Likely I have 1. So that's, I change the categorical variable to a dummy, right? It's 1 or 0. Okay, because that is how you convert the nominal variable to number, or ordinal variable to number. Okay. And then because depend on the cylinders, right? You either use 4 or 6, then your 6 is 1, either you call 0. Okay. And then also look at age, and you may ask why I want age at a squared, because when you get older, right, the price would drop slower, right? Because when it's young, the age goes, then it drop very fast, right? But when you're getting older, that doesn't drop as fast as you expect, right? So that's why it's not linear, right? It's dropping, initially drop faster, right? So that's why non-linear. Same as odometer, right? How far you have driven, right? For the first 10,000 miles, it dropped very fast, right? And slower, it drops slower, right? The price, okay? It's non-linear, so that's why you have this. So the moral is, if you think it's not linear, then you just add square. Okay. Whether you add cubic depends on, you run the regression, you know whether you need cubic or not. Okay. So the model is fairly simple. To set the price, you want to use how old they are, and then model 1 plus how long you have driven, and also add some conditions. Okay. And also with the dealer condition. Okay. And that is the regression. I just put it there. And then you have 5 regression there. Of course, you can say you have 5 regression. The easiest is to write a loop over the regressions, and you just append it into a single regression. Okay. So you just starting, you run it, right? But you have a list, you append all the equation into one big list, okay? And then you can run regression, okay? So remember, every time you run regression, you fit the result in the list, okay? You have your loop, you loop over there. While I do that, once I do that, I can display the results. And here, you will see this is the regression. I don't care about the numbers because it's not my concern, right? Because now I only care about how I fit the model, right? So I actually don't care about what is the inside, okay? This is different from what we have before, right? Before, we still want to look at correlation, right? Whether look at stars there. When you purely look at prediction problem, we only care about how good the prediction is. So R square is the thing that we care at this point. We no longer care about whether the coefficient is there or not. Right? Of course, there'll be some reason we care, but the main thing is R square. Okay, or adjust R square. Okay, that's something we care. Okay, so that is the model we have here. Okay. Now, of course, the question would be, okay, we have the model, now let's do the prediction, okay? Now, if we give you a particular car with H12, H10, odometer 12, type is LE, and the excellent condition, and then non-dual, not six-cylinder, and this will be the model give you, okay? And you will say, okay, 5 different model, give you 5 different price, then you want to sell the car, or you want to buy this car, what should be the fair, which one to pick, right? Or you want to put this car on sale? I think this is the question they propose, okay? And these are all the 95% prediction interval, because you predict only one car, right? Not average. You want to sell the car or to buy the car, so you only the PI, so the range is pretty large. Okay. So this is how you input it, your data there. Okay. Once you input the data there, then you can do the prediction. Okay. And what you do is you start the prediction and you can fit it into all the model you're predicting. That's a for loop. You're going to loop over all the equation one by one. Each model, you fit this data. Okay. And once you fit the data, you get the prediction based on your number. Okay. And you fit 95%. Okay. And you put the prediction into your priest, right? Predicts. And once you do it, you combine it. Okay. This is what the result is. And this is the mean estimate, SE and CI and PI, right? So this is what I write down there, and this is all what I write down from there, right? So this is this line and this line, right? Is how I get this number. Okay. So this is prediction. Do know that I do not care about each coefficient. I just use a prediction. Okay. I really don't care about whether we have 3 star or 1 star or no star at all, because prediction is my goal now. Okay. Same as all the machine learning class. We don't care about star anymore. Okay. Only if you want to say something, then you want to say star, right? Now the question would be, I have 5 models, and the price are very different, maybe something like 6,000, but still they are different enough. The question is which one to pick. Okay. Of course, you can pick based on R square adjust, or there's other way to measure that, but we give you how to measure those. Okay. But at the moment, okay, we will be looking at how to fit them. Okay. So the thing is, we want to avoid overfitting because overfitting is the most common problem when you do prediction, right? Because the sample has a lot of feature that may not be in the population, right? Because prediction is what? You use the sample feature, right, to generate our model. But overfit means that you fitting a lot of things that's so close to the data, and those feature and data actually not in the population. Okay. So that's why, in general, you don't use the most simple model, not most difficult model, somewhere in the middle, right? Actually, what the Kongji said, right? 中庸, right, is the middle. Not too big, not too small, right? It's the Goldilocks idea. Okay. So that's the idea I actually see. Okay. The Goldilocks idea is like this. When you fit the data, the increased number of parameter or coefficient actually always reduce. Okay. Because you small thing actually will fit better no matter what. But the problem, when you actually fit your real data, you go down and up. Okay. So that's why you figure out that somewhere in the middle is good. Okay. So not too complex, not too simple. Okay. And actually what the machine learning tells you. Okay. This is what we discover, right? Don't overfit. Okay. Of course, large language model is different. Okay. That's if you know, that's what we call the double descent, but let's forget about this. It's always like this. Okay. It's always a U shape. And how to select the model? Okay. As we said, we know already. First one is R square. Okay. We said already. The other is MSE. Okay. The other one is loss function. The loss function we have said already. Loss function is sum of square error. You can take a log on that. Okay. And their method, okay, to do this is only the fit, but they didn't punish the complexity. Okay. That's why we just learned adjust R square, which would punish if you add redundant variable. Okay. And there's another thing called AIC and BIC, which I'm not going to give you the explicit formula because I give you that's no point, but basically just something combine these two. Okay. And these two will use it. Okay. And this is direct comparison. And this next one, probably also learned in the machine learning very well, is called the cross validation. Okay. And you divide the data into several parts, test part and training part. And you fit the data based on the training set and validate based on the test set, right? You learned that from machine learning. And you also use the K-flow cross validation. The cross splitting, you divide it into multiple parts. And first set, they will say in the 5 parts, the first part taken as the test set, the other 4 parts is training, but you swap which part become a test set, right? Then you do many times. So I see many of you noting, so I will go very fast. Okay. So we will show you that using the full data, you depend on what method you use. RMSE with model 5, R square, model 5, and just R square is still model 5. Use BIC and AIC with model 3 and 4. Okay. So still not sure which to pick, but you have to make up your mind which one to pick. Okay. But still, at least you will know which one to pick. So since many of you have seen it, I go very fast. Okay. So we will have used a stat models .2.evaluates .rmse. Okay. So you've seen this there. Okay. We do evaluation. Okay. So what we do is, because remember, our model equation have 5 regression. Okay. Remember 5 regression. So we loop over a counter, an equation in this variable, right? Because enumerate is a Python code, means I means the counting 1, 2, 3, 4, 5, right? And equation, because we have 5 equation here, so this is looping over equation. Okay. And first is y, okay, is equal to, because the equation have it's like this, right? If you remember, what's the equation here? It's like this thing, right? The equations. So y is this string. You before the snail is the y. After snail are the x. Okay. So then what I do, this code is y is the equation. You split 0 means the first one. The strip means take out the empty space. So just take out the y variable. Okay. And the model will be just ORS equation, the data, the fit it. Okay. And RMSE, okay, it just using the model do the prediction, and this is the y, right? Because RMSE is you put the y head and the y, right? Give you RMSE. And some of you would ask why I don't use the covariance. Doesn't matter, because covariance just affect the error estimate, doesn't affect the prediction, so you don't have to do that. Okay, you do that the same thing. Doesn't help. Doesn't worry about it, because that's affect the standard error calculation. Okay, so that's RMSE. I'm sorry if you have listened. You know very well, but I just go one by one. So output is the model, and model because I counting 1, 2, 3, 4, 5. I put a string number 1, number 2, number 3, number 4, starting from 0. Model 1, okay. The coefficient is coming from the model coefficient, right? And RMSE is just we calculate. And R square is just based on the model R square. That's very simple. Because regression, you can just there. R square, so be R square adjust will be R square adjust, okay? And the BIC, AIC is model.BIC model. It's very simple. Everything is already inbuilt there, right? Why? Because when we run the regression, if you remember, with the very beginning, your regression should be less than 5. Okay. When you run regression, it's right there. R square, R adjust, AIC, BIC, are all there. Okay. So basically, you can just extract them. Okay. It should be R square adjust here. Sorry, I just a typo here. Okay. This is right, but I don't know. The code is not right here, but the output is right. Okay. So you can see, I don't want R square. I just R adjust, right? You pick up the largest one, which is this guy. Okay. And AIC and BIC, you are not picking them. You'll be picking based on the smallest one. Okay. So look at BIC, which is lowest, the third one. Look at AIC, the smallest is the fourth one. Okay. So the question is, which one you like the best? I don't know at this point. The winner is 3 and 4 and 5. 1 and 2 will be gone. Okay. And probably you want to do more because remember, this is based on the whole sample, right? So probably we want to use the validation method. Okay. We want to train the model based on some data and test the model based on the other cell data. Then we'll have a better guess which ones fit better. But if you use the whole data set, these are the model you fit, and you can pick either of them by citing this, also fine. To me, they are roughly similar. So probably maybe I would pick 4 if you ask me, because this is very similar anyway, and this is much bigger than this guy, right? And I think this is okay. I would pick 3 or 2, but I will pick model 3, model 4. But model 5 is slightly more complicated than my taste. But anyway. So let's see what we get. Okay. Surprisingly, when you see, let's do the validation is I take the data, I train the data based on 7% of data, and I evaluate based on the remaining 30% data. Okay. Turn out that use RMSE, 3 is winning, R square, 5 is winning. Use BIC and AIC, 3 and 5 is winning. So 4 is gone, unfortunately. The one I like is gone, but you have 3 and 5. So how do you run this? We'll use a Python module, you know where we are for machine learning. It's called the skip-learn model selection. Train test split means that they randomize the data to pick it out. Okay? And it will do this train test split your data. You tell them how to cut it. Okay? And you random state is the random seed. Okay. If you put any number you want, okay. But you fix this number every time you run the regression. Sorry, any time you split the data will be the same. Random seed there. And this will give you train data and test data. Okay. I think you learned it from your other class, right? So I don't want to bother you with that. So again, the same. I have stat tools, evaluate, measure, RMSE. Validation, I loop over all the models I'm running. First, I get the Y variable and I fit the regression. Only difference I based on trained data. Okay, so only difference is this guy. Before it is DF, but now it's DF underscore train because I fit the model based on trained data. And when I calculate RMSE, I base on the text data. See, I base on test. And I compare the test one. Okay, so I fit the model based on train. I evaluate based on test. Okay. Then I do the same. Okay, this is the same code, so I'm not going to repeat myself. Okay. Because BIC, AIC are the full model, so you don't have to worry about this part. Okay. So that means that, okay, my BIC is this one, AIC is this one. Okay. And I want to RMSE this lowest is this one, R squared this one. So that is my model. Okay. Now the next is what we call cross validation. Okay, which I noticed some of you look at the clock. So I noticed, okay, I will not talk about this, but the idea is, let me finish this graph. I'm not going to code. The graph will be the following. Okay, you do the same. You just train the data based on blue, test on the red. Okay, that will give you a MSE for this model. Okay, you do the same. Okay, and every time you have to test and train RMSE, and you average of these trained or test RMSE, and then you do the evaluation. I mean, I'm sure that you learn from other machine learning class as well. So I go super fast, but because I want to be a complete story. Okay. But anyway, as promised, have a break of 15 minutes, and once done, come back for a quiz.
There's bad there. Oh.我以為如果考試，我以前我三老師。太簡單，佢又帶，我係我想講，你點係要啱佢嘅？咩啊？我都很奇怪一點，成日轉講嘢。
有咩？有㗎，我要寫字咯。
你睇呢個版你先會寫翻俾，跟住都埋其他咧用嘅。因為我成日都有呢個講笑嘅，我明嘅。
我星期六病嘅，但係病嗰成2日都係瞓喺床。
即係你
唔係今日早咗多啊！我想搞嘅㗎，今日都係因為我發覺我琴日搞得太慢，搞得暫時咯。因為後呢啲咧，我覺得好似都好多人嘅水分就我。我聽到啲人即係個幾條問題啦，即係我得咗10條啦。佢抽唔 我哋唔係睇你想答。睇你嘅題目嘅。其實 interview 你就係 marketing 我哋最講呢啲唔同但係而家佢你要俾佢即係。我覺得係因為如果經驗咯，呢個多好多經驗唔夠有，但係嗰啲唔係嗰佢呢個就係啦，好多人即係佢冇咁大，咁大，其他嚟講。咩啊？即係我得㗎啦。要你啲，我睇你咁講啫嘛，唔使呢樣嘢。即係你亂噏有同佢得嘅，但我錯唔喺個聲，佢會講。咁叻我都唔使成個成啦。好，咩做？我懷疑大家都開始咁。拉都冇辦法啦，係咪先？我俾你講，我俾你玩車架講咩？首先係開我半成即係我做非常間你提供嚟你買機俾下你用至少你起碼睇下個公司啦，係按咗都唔睇下真係好貴，即係逼你睇下先。即係點解我同你俾翻你？就逼你條幾化睇下，所以我最起碼話嘅房屋市報嗰時候講解嘅，咁我都唔係好驚。 So I predict a prediction. In the age example, P is smaller than 5%. So P smaller than 5% means that you will reject the null that the coefficient is less than 5%. I suppose here we mean this regression, right? So we see this, you reject this from 0. This is okay. And this is not okay. This means that the coefficient of female is not different from 0. So although it looks like negative, but it's not different from 0. So in convention, we say this is 0. So basically, there's no gender gap by itself. The gender gap comes from the growth with experience, right? So that is the model here, right? So it's what we say is there's no difference when age is 0, but when experience grow, there's a difference here. I hope I explained that. If not, then I'm happy to explain after your quiz is over. Too fast. Okay, I try to see if it is if too fast, I would try to explain again. Ask me, because always it will be too fast or too slow between. I mean, just like the model, right? Middle is the best, right? But when you do middle, then always too fast for someone, too slow for somebody. Okay, and I don't I'm unable to solve this problem always because as I explained to others, some of you will see because of this is a part-time course. It is people come from very diverse background. Some people have very heavy workload, and some people have very laid-back life, right? And right, not pinpointing which type of employer working on, but some people do have more free time. So very difficult to satisfy everyone. Okay. So, but let me open this exam. So I only allow you submit once, right? And I will set 25 minutes, right? To be 30 minutes, 30 minutes, 35, 30? Okay, 30. You can submit anytime you want because I think 30 minutes all at once. I randomize question to forbid you picking the others. Okay. And I now make available to you. So it's open book, open notes, not open to AI, not open to WhatsApp or WeChat. I go around, so please don't talk to each other. Do your own work. And now you should be there. You may start now. Let me know if you should be there. Okay. So don't worry, as long as you more than half, then you get the full credit. Okay? Even if you do nothing, you still get 1 point. Okay. So don't worry too much. For those who leave early, have a nice 重阳节. Enjoy the hiking. So around 20 minutes remaining, 1/3 of time has been passed. Simple. Okay.
Already done those questions. It's fine. So this one is basically about the group assignment. And that's a simple choosing a topic of what maybe comes through. So I see that is so I found this yeah, they're right. It's a good yeah, so I believe that this was supposed to be about the classroom, which is getting such a kind of problems. And I discussed with my company's colleague, and they said yes. So again, the topic of those pure questions. So sometimes the beginning have a high income, really bad feedbacks. Sometimes the beginning have a lower income, good feedback. And so I'm just wondering, like, if the pure question is talking about the factors how the gaming will be success. Should I focusing on this or on other? Okay, one factor. So one factor you can I do believe in that have a higher player number. The data is I got data from
a lot of data as well.
yeah, there's data from Steam. This one is a Steam player. Yes.
They only have very little quality.
On this one. Anyway, about这个7-1我们介入。
所以你找什么 data？
因为我把7-1放在这里，然后本来还是应该是差不多这个点，但是我传从这个，然后他就看到我的7-1 questions， 那个。All the data from things about like new sounds of gaming, all the details, from this stage. First time searching describe. So sometimes the analysis should 因为人数这个东西它确实不好把控，因为我也不太清楚应该如何定义
这个商业成功受欢迎的话，
受欢迎的，
这个反正就是
但是我也，但是
不叫做。Focus on something most.
Maybe second one or
我们一般都给 why the rating low or another way. Why they're large.
sometimes it's more interesting. like for our like gaming industry company, what kind of gaming like first person gaming or RPG or things like you focus on? Like what kind of getting like constant just how flies or how to
Even you do one question, if you do it carefully, right? You do it high quality, only one question.
Because I probably I do believe I need to submit this assignment to my company as well.
Okay.
I'm uploading all the just using like AI to supporting like just
Yeah, but you I有就是
yeah, of course already most otherwise if you put it on GitHub will be weird, right? Okay. Search for that.
It sounds good.
Sounds good for you.
Any three of them will be fine. Because you're one person, right? So any one question you want. Of course you can answer three of them.
The one page is kind of limit. If I want to write down the laws or
Well, always you. In the end, where was it? I don't know. That's answer.
that will work. Even animation challenge,
right? Icon number one, the first factor, second factor,
don't need to see.
so the result. You must learn it just so me to impact factor, right? What 50%, 40%.
Oh yes. Make it person.
客气客气，打游戏的电脑，谁也
作为人做要
不要打，
经常要打，还有许多测评。
挺好的。我没时间玩游戏的，年轻的时候打游戏，现在当老师没时间打，孩子都不打了，孩子都没有时间打，就天天打，我的孩子天天打，我现在就考试没时间打。
你之前打什么？
我之前打啲小孩子游戏啊，都以前我打什么，大学的时候打那个世界帝国
啊，世界哦
，Empire Rainbow Six 啊
Rainbow Six，我之前打他的职业赛。
Six 啊，这些老游戏咯。
是哦，
很老了，我的老的时候打，后来都不打。
Rainbow
Civilization 啊
Civilization，
什么三国啊，这不太少。
你有听说过 Delta Force 吗？
我有，
我现在这个上面是 Delta Force，
红底的什么的
啊，
老游戏，对，现在打不动了。
Study is way more important than gaming.
It's more fun. But I mean, of course, gaming is still fun. But just too old to play gaming.
Not really. Gaming is designed for all the ages.
拜拜。好，再見，再見，再見。行山快樂。
係啊，蘇華係我哋而家諗住一傾緊啲嗰個 group project 啦。咁我哋有個
停咗先。啊，咪等埋7點你繼續講。
咁我哋咧就諗住揾啲交通意外啊數據去做嗰啲個 project。其實我唔知而家個 project 個 theme 係，即係我哋做個 set 係咪見？因為我見到好多唔同 model 啊，就我哋
得一個 model 喎，都 regression 喎，冇教其他 model 喎。我哋教咗 regression model 冇教其他嘢喎。
唔係好多個 chart 我見到真係好多啱講。
哦，咁係唔同嘅 regression 裏邊可以用唔同嘅 model 嘅，都係嗰個 model 嚟㗎。
哦。
我教咗嗰個 regression 嚟㗎，冇教其他嘢啊，我仲未教。我都冇嗱，我冇教 logistic 又冇教 regression 冇，我淨係教 regression。就算我教 Lysol， 你話嗰個都係 regression 嚟啫嘛。
我都唔識分，即係我見到有咩頭先嗰啲
教咁多都係 regression 嚟㗎咋，我冇教其他嘢咯。我就教 regression 就冇教其他 model 啊，冇
咁我哋
屈我。
咁我哋係
regression 嚟㗎，你哋所以做 regression 嘢，我就教 regression 啫嘛。
即係唔係 X 同 Y 咧，定係仲有多啲嘢？
我 X Y 即係 A B C 好多㗎，X1 X2 X3 㗎嘛 ，multiple 㗎嘛。
哦，係我哋咁我係咪話譬如我因為我話 machine learning 嗰個有冇各方面個 project 分係
machine learning咪就係你乜都唔理咪照塞咯。machine learning 係一堆好大嘅嘢跟住自己 learn 㗎嘛，咁但係我哋 regression 頭先嚟講，我哋係要自己諗下係咪啱，唔可以亂塞噶嘛。
即係我哋諗
我哋頭先嗰啲揾解釋車嗰啲唔係亂塞㗎，咁個我哋而家唔係亂塞嘢㗎。
即係我係咪揾翻個
即係要 reasonable 嘅，你溫出嚟個 regression，我真係唔使啦。係㗎，多謝啦，多謝，感謝你嘅蛋撻。
哦，下次你想食咩？我送大陸大翻俾你啊！
好，多謝。我而家咳嗽唔食得嘢喎，
哦，
奇怪嘅，多謝，得好多謝啦，多謝。咁啊，
面嘅選手我覺得
係，我係。
即係而家就總之係，我可唔可以話係，即係某啲地方嗰個 step 嚟嘅，就譬如某啲地方係啱多啲即係交互度關事，因為而家係要有，反而有兩，我記得有兩個 purpose，一個就係呢個 A cos B 嘅原因啦。
有嘅，我哋下一兩堂會教，盡量睇下教幾多，我想教 causal，但係
係咯 causal 啦
causal，但係我而家 regression 如果我哋係唔係算嚟嘅，我哋係亂塞，唔係算嚟嘅亂塞嘅，我哋照對㗎嘛 prediction 嘅啫嘛。我哋而家冇，我哋未教 prediction 先，so far 我哋嗰啲都覺得係有關係嘅。
係咯，一係教
我哋係純粹係擺咩落去係我哋有道理㗎嘛，唔係亂擺㗎嘛。
哦，即係我哋都係 base on 覺得呢兩個 variable
有啲嘢喺度嘅，我唔係亂塞㗎，我唔係夜觀星象話個月亮喺邊度塞落去咁都得嘅，係咪先？但係嗰啲就好似你溫出嚟都唔信啦，係嘛？咪俾睇風水咯，呢個情況。
係咯，即
係
嗰個
係咯，
即係我哋啲文字就解釋翻呢個。
係咯，咁你睇要你至少吹到出嚟㗎，你溫到 calculation 之後，你話俾你聽，你亂塞嘢啦，你唔解釋你咪 black box 即係變咗咩出咪算得嚟咯，你唔詳細解釋咪算得嚟，我哋詳細解釋係 calculation 嚟。
即係總之聽落去都 reasonable，我哋其實都啱一聲聲。
咁你逼到個聲，你吹到牛出嚟，咁咪都算你 regression 咯。
係啦，
你麥酸嚟就我唔理㗎啦，麥酸靚咗㗎嘛，麥酸嘢你攞鬼知啊。
係啦，總之我唔知點解咁大堆。
係啦，總之佢整得最靚仔就得㗎，就咁啊麥酸靚嚟咯。咁所以就咁咯。呢個科同我個科就係個科分別就係我哋做完嘢之後，我哋睇下個 P value 係咪要抵嚟，咁麥酸嚟 care，咁我就唔得上嘅啫嘛。
係我即係我哋過程係即係我哋都要做埋可能啲整劑 outlier 啊。
係啊，我哋要做好多嘢㗎，但佢哋麥酸嚟唔俾㗎嘛，話知佢死啦，總之懟落去麥酸靚就搞掂。
哦，唔係佢哋都有啲 function 係幫手，即係整走。
佢有啲嘢嘅，但係佢唔好 care 嗰啲，即係咁多點樣整啫？
係咁啊係，
自己個 million 幾個 billion data 點樣搞啊？人手去捉咁咪真係冇可能做到啲嘢嘅。
哦，
點樣做？冇可能做到。你試下俾 data，你成堆 data 嚟講
OK，
冇辦法做佢。
哦，咁都係咯。
有啲可以做嘅，但係佢都唔係做到好多。
哦，
佢都係佢 mechanical rule 去做㗎嘛。但係我哋依係好即係比較 business 啲嘅。
係咯，即係呢個係冇咁勁嗰陣時嘅，嗰陣時就係整
係咯，整。
係咪 B.I 係咪你以前啲人話？
係啦，差唔多啦。B.I 做啲都係。
係咯，
即係有啲度，即係講出嚟講到故事嘅咯。我哋嗰度做，你講唔到故事咪算得嚟啦。即係純粹唔同你講故仔就係硬做出嚟就咁真係咁啦，就係咁啦，你信我啦。
係咯，即係
啲係咁對出嚟對咯，咪
即係吹。不過我想問 LLM 我哋冇得讀嘅，或者再了解我哋即係之後。
有，但係唔係我哋可以教，唔係我教你㗎啦，就係有人教，但係有得教咪就係 LLM 咪就係一堆 regression 嚟做咯。
哇，係咯，佢再應該係
就係點講 level 啫嘛，係無限即係 regret 完就 regret 係咁 regret 啫嘛。如果你睇下啲 video 條資料就係佢冇勁多 regression 啫嘛。
有啲嘢㗎，即係佢嗰啲
即係好大係咁。我兩個嘢識。Yeah, it takes one, it takes 咁你就會 fit 咗呢堆嘢 random regression， C1、C2、C3。呢個 random regression， 我先嚟 pick 呢個俾你 random regression， 咁樣又再 random regression， 咁樣又 random regression， 跟住就繼續睇落去，好多層。跟住落俾出數據先，
跟住我可能復嘅就係
Y1、Y2、Y3，係啊。
佢唔俾你最高。
係啊，咁係咁對啫嘛，好層啫嘛。
冇乜價錢。
咁所以點解近期先有啫嘛？呢啲80年代就
我
諗翻有人哋又係做出嚟咯。咁呢個無人腦啫嘛，人哋咁咯。Exactly your brain, that's what happened. OK，講晒阿 Sir，點啊？大家聽唔到？點啊？做完啦嘛？
要加長。
我哋啱啱傾緊我哋 stand 嗰個。
我可以收呢個收工先。
收㗎啦。
唔係呢個唔係 keep 住呢度，好似都離開晒，得翻我哋。